the first question here is a pendulum. So we're going to use the formulas. Woo! Awesome. So many chairs over here. So little time. Like, why is there 2 chairs right here? Okay. So if you look here, this whole right-hand side is the formula sheet. The very top of the formula sheet has theta equals A over R. Yeah. I told you to keep the first one from your first unit test. So we have theta equals A over R. Now these are used in instances where you're given a circle where there are portions of the circle that you're looking at. So, for example, here we have a pendulum that is 30 centimeters long. So it's hanging from somewhere. Here's your pendulum. It's 30 centimeters long. Swings through an arc of 45 centimeters. Now, if we kept going around, this would be a full circle, correct? So it says, through what angle does the pendulum swing? So you're trying to figure this out. So if you go around the entire thing, it'll make a full circle, correct? So what would the 30 be then if that was a full circle, the radius? And this is your arc length. So on your formula, that's your arc length. That's your radius. And this is your angle in radians. Okay. So it has to be in radians or you can't use the formula. So often what they'll do is they'll give it to you in degrees, and then you have to convert it to radians to use the formula. Or they'll make you solve for the theta, and they'll ask for it in degrees, because your answer will be in radians. Okay? So let's fill it in. Now, your A and your R have to be in the same units. If they're not in the same units, you have to make them in the same units, okay? Because the units will cancel. So we have theta equals A, which is 45 centimeters, over R, which is 30 centimeters. So theta equals 1.5. Now, we could leave it as just 1.5. If we leave it as 1.5, it's in what unit? Seriously? No. It's in radians. So I can leave it as 1.5 and that is radians, or I could write rads behind it, or I could write radians behind it, or I could leave it as it is. It doesn't matter. If I don't write anything behind it, we assume it to be radians, because the only way we know it's not radians is if there's what? A degree symbol. Now they also want it in degrees, and honestly, they probably would want this in degrees. So how do I convert from radians to degrees? Pi on bottom. So what's 1.5 times 180 over pi? Put it into your calculator. 1.5 times 180 over pi. $85.9. The next one says, calculate the arc length to the nearest tenth of a meter of a sector of a circle with a diameter of 9.2 if the sector angle is 150. So calculate the arc length. So we need to find A. With a diameter of 9.2, what does 9.2 help us find? The radius. So the radius is 9.2 meters divided by 2, which is 4.6 meters. And they have theta equals 150, but I'm not even going to write the 150 down because then I might feel the need to put it in. I have to put the 150, and then what do I have to do immediately right after I put 150? Yeah, so degrees to radians, pi on top. So times pi over 180. So you're going to get 5 pi over 6, I believe. And then we have to solve for a. So theta equals a over r. Multiplied by r. And a equals r theta. So a equals 4.6 meters times 5 pi over 6. And so what do you get? 4.6 times 5 pi over 6. $12.0? 12.0 what? Nope. 12 meters. Instead of doing this question, I'm going to give you a made-up question, okay? So we're going to do one where they want the perimeter. So we're looking at a pi piece of land, okay? And this piece up here, we're going to say we can't have any type of plants in it. We want to plant this part. And I want you to tell me the perimeter of this part. The perimeter of the shaded region. Okay? Now, what I'm going to give you is this angle is 45 degrees. That angle is 45 degrees. This little piece here, I'm going to say is 10 meters. This piece here, I'm going to say is 30 meters. I want you to give me the perimeter of the red area. Try it out. Okay, so to get this little arc length here, I'm going to go A equals the radius times theta, right? And theta is 45 pi over 180 because we need it in radians. And then I'm going to add to that what? This arc length, which the radius is actually what this time? 30. And then I also have to add this length, which is what? And this length, which is? So it's 71.4 meters. Okay? Flip over. So these are definitions. Coterminal. Coterminal angles are angles with the same terminal arm. So for example, if I had the angle 45, to get a coterminal, I could just start here, go to 45. I'm going to have to keep going around and then come back to here, and I land on the exact same terminal arm. So what did I actually do then to find out what that angle would be? 360 plus 360 got me to here, plus 45. So it would be 405 would be coterminal with 45. So if I drew 405, it would land on 45, same terminal arm. Okay, that's what coterminal means. Reference angles, you did this last year, are the acute angles, the cute little angles. They're between 0 and 90, between the terminal arm and the x-axis. Your reference angles, if you found each of them, would make a bow tie. So if I had this angle here, my reference angle would be this piece, would it not? If I had an angle in this quadrant, my reference angle would be this piece. If I had one in here, my reference angle would be this piece. If I had a terminal arm in this side, my reference angle would be this piece. So they make a bow tie. They're not going to make an hourglass. You never figure out the angle from the terminal arm to the y-axis ever. It's not helpful to you. There is no help for that. The reference angle is always from the x-axis to your terminal arm, and you used them last year. Okay, so knowing that, let's go through these. So sketch the following rotational angles, give their reference angles, and give 2 coterminal angles. So 60. First thing I'm going to do, label my axis. 0, 90, 180, 270, 360. I would promote you to because it's going to get a lot harder than it is right now. So 60, give our arm here, and then 30 away from 90. So this would be 60, right? Now the reference angle is the angle from that terminal arm to the x-axis. So what would the reference angle of this one be? 60. So actually any angle in the first quadrant is its own reference angle. Okay? So the reference angle here equals 60 degrees. Now, coterminal, what did we do? We added 360, and it's got us to the next one, correct? Next positive. So 60 degrees plus 360 is 420. If I take 420 degrees and I add to it 360, I'll get 780 degrees. All of those, if I keep drawing them, will land on the same terminal arm. They just get an extra little like corkscrew in them, right? That's it. Now, the catch is that once we hit 30-1, we also did negative angles too, right? So we could find coterminal angles in the opposite direction as well. Instead of adding 360, we're going to subtract 360. So we get negative 300. Now, is that true? Well, if I come from here and I draw negative 300, I will land on the same terminal arm, will I not? So it is coterminal with it, because I would terminate on the same arm. You guys try D, and then we'll do the radian ones. Okay, if we go to draw 300, 0, 90, I need degree symbols, 180, 270, 360. 300 is 60 away from 360 or 30 away from 270, as long as you know to draw it appropriately. Starts here, and it circles around to this arm. So that's 300. What's my reference angle? If I drew the bow tie towards the x-axis, it's going to be 60. Now, because 2 of them were 60, we must then assume that every reference angle to life is 60. No. It just happened that these 2 were both 60, okay? So we have a reference angle of 60. Coterminal. I didn't really even label that last one. So there are infinite number of coterminals, right? So if they asked it as a multiple choice, they could just give you one that actually works, right? It could be the one that you add 2 360s to. It could be the one that you subtract 2 360s to. But you'll know that it's that one. Other way they could do it is they could restrict your domain. So they could ask for the coterminal angle between 360 and 720 or something like that, and put it in a numeric response if they wanted to. Okay, so we can go 300 plus 360 and get 660. We could do 300 minus 360 and get negative 60, which makes sense because if I work my way back from here to here, it's negative 60. If I go past here and past here again, make that little corkscrew shape, I get to 660. All right, 5 pi over 3. 5 pi over 3 is in radian measure. Now, if you look at your unit circle, it's actually one that's on the unit circle. But say you didn't recognize that. What might you want to do? Change it to degrees. Is it okay to change it to degrees? Sure. You can probably draw it better. The catch, though, is if the question is in radian measure, your answer has to be in radians. So you can do it all in degrees, all fine. That's okay. But at the end, you have to convert back. You can't give me an answer in degrees. Okay? So 5 pi over 3. What's 5 times 180 divided by 3? 120? I think. Yeah? No? Maybe so? No. 5 times 180 divided by 3? Don't know. 150? What's 5 times 180 divided by 3? 300. I was way out to lunch. 120. How is that even? Like, that's not even close. Okay, 300. So we're going to actually get the exact same graph. But we're going to label it what? 5 pi over 3. All of our answers are correct. But what's the problem with the answers here? They're in degrees, and we're going to have to convert them. So 60 is what? Pi over 3. Good answer. 60 is pi over 3. 30 is pi over 6. 45 is pi over 4. Those ones you will use a lot. You need to memorize them. Coterminals. I'm so glad you listened. If we didn't actually want to convert them and we just wanted to make it a coterminal with the radian measure, what we did was we added 360 when it was degrees, right? What is 360 degrees in radians? 2 pi. So we could just add 2 pi. So we could go 5 pi over 3 plus 2 pi. Now, if we wanted to put them in our calculator and do it that way, you would just go 5 over 3 plus 2 and then add the pi after. Or you'd have to do the actual math. 5 pi over 3 plus 6 pi over 3 by making a common denominator, which is 11 pi over 3. So 11 pi over 3 is the same as 660. And then our other one is negative pi over 3. Negative 60. You guys try negative 2 pi over 3. Okay. Exactly. So negative 120 is what this is. Negative 2 pi over 3. So what is my reference angle? It's going to be 60, which is pi over 3. They're not always 60. We just happen to have every answer here be 60. The reference angle is pi over 3. It's not negative. Your reference angle is always positive because it is the distance from your terminal arm to the x-axis, and therefore distances have to be positive. It's not a displacement. Okay? So your reference angle is positive pi over 3. And then your coterminals, you could go 120 plus 360, which is 480. No, it's negative 120 plus 360. So it's 240. Or negative 120 minus 360, which is negative 480. But then you'd have to convert them to radians, right? You could do that. So you could go negative 120 minus 360, which gets you negative 480 times pi over 180, which is something. What's negative 480 divided by 180? Oh, it's going to be 60, negative 8 over 3. Now, if you wanted to do that without converting it to degrees, you could literally just go negative 2 pi over 3 minus 2 pi, which is negative 2 pi over 3 minus 6 pi over 3, getting a common denominator, which is negative 8 pi over 3. Because you're just subtracting 2 pi. The other coterminal would be, I have no room, negative 2 pi over 3 plus 2 pi, or you could go negative 120 plus 360, which is positive 240, convert that to radians. Four pi over 3 would be the other one. Okay. Flip over. We're actually going to go down here. Okay, so note to self. This is a side note I didn't realize I didn't tell any of you and has absolutely nothing to do with this unit. But if you're in your y equals and say your graph is being drawn and you know that you accidentally hit the wrong thing and you want your graph to stop and it doesn't stop and you have to wait it out, you don't actually have to wait it out. If you just go second on, it stops it. So type in y equals x squared plus 3. Yeah, which means it stops it. Yeah, it'll pause it. It doesn't actually turn it off. It just pauses it. So it'll at least stop it, right? Because often you can't get it to stop until it finally stops. That's one thing. The second thing is, okay, until now, you guys have been able to always, your teachers reset your calculator and then they say, don't forget to turn it back to degrees or else you're going to get everything wrong. Not the case. So this year, you're going to have degrees and radians. You're going to be floating and flipping back and forth. It sounds a lot more confusing than it is. It's not really that hard. So you only have to be in specific degree or radian mode when you press 3 buttons. The sine, the cos, and the tan button. If you press the sine, the cos, the tan button, or second the sine, the cos, the tan button, which is the inverses up behind it, if you press any of those buttons, you have to be in a specific mode, either radian or degree, depending on what the heck you're putting into your calculator. Okay? If you touch any other button around those, the mode does not matter. So when your cumulative comes, and I moved it to Tuesday, when your cumulative happens, and you call me over and you're like, Mrs. Lepp, what mode do I need to be in? And I say, are you pressing the sine, cos, or tan button? And you say, no, and then you say, well, what mode do I have to be in? It doesn't matter, okay? So the cumulative on Tuesday has no trig in it. So the mode, you could have it in either mode, it's not going to matter. It only matters when you press those buttons, okay? Now, how do you know what mode to be in? You know what mode to be in depending on what answer you need. So if you want your answer in radians, your mode has to be in radians, or by what number you're putting in. So look at the first one, it's sine of 30. Sine of 30 what? Degrees. So what mode do I need to be in? So press mode, which is by your second button, and make sure it's bolded over degrees. It's 0.5. Now go to your unit circle. Go to your unit circle at 30. Go to your unit circle at 30. Now look at the point. The point on your unit circle. Which part of the 30-degree point? The y value, right? Now go cos of 30 into your calculator. It's root 3 over 2, but root 3 over 2 is 0.8660, right? So if you go cos of 30, it gives you 0.8660, doesn't it? So if I want an exact value, you'd have to look up your unit circle to get the root 3 over 2. So, paying attention, all of the x's on your unit circle are answers to cotes of that angle. All of the y's on your unit circle are answers to sines of that angle. That's what you were taught last year, okay? Tan is sine divided by cos. So if you want tan off of your unit circle, you'd actually have to go y divided by x, because it's sine divided by cos, okay? And tan is y divided by x. You were taught that last year too. Now, put sine, yo, what's up? So, sine of pi over 6, how would we put it into our calculator? Yeah, but what does your calculator have to be in? Radian mode. So go radian mode, go mode radians, and then go sine pi over 6. Weird, you get 0.5. What is pi over 6 radians the same as in degrees? 30. A and B are the exact same. But if you put sine pi over 6 into your calculator in degree mode, it does not give you 0.5. Now, put in sine 1.57. Now, let's think about that. Is there a degree symbol? No, so we assume it to be. So sine 1.57 is what? 0.999999, which is 1. Now, cotan of 70. Lovely. This is something to note. And on your formula sheet, it even tells you this. Shh, pay attention. So you had sine, cos, and tan. You're also going to have cosecant, secant, and cotan now. So sine theta, cos theta, tan theta are ones we know already. Okay? Another one that there is cosecant theta. Cosecant theta is 1 over sine. It's just like the flip of sine. Secant theta is 1 over cos. And cotan theta is 1 over tan. Now for those of you who are freaking out, all 3 of those are on your formula sheet. No memorization needed. They are there. It's not bad. So if they give you cotan of 70, the only way you can plug it into your calculator is 1 divided by tan of 70. Now keep in mind, it's 70 what? So your calculator needs to be in? Yes. So the moment you go to press the sine, the cos, the tan, the second sine, second cos, second tan, you need to stop yourself and say, wait a second, what mode do I need to be in? So every single time you go to press that button, stop yourself and be like, wait a second, I need to be in a certain mode. What mode is that? Every time, because the mode could change. Now, could you technically convert your radians to degrees and then put them in all as degrees? Sure. It would be time consuming, but you could. So make sure that you put them in appropriately. Now, your homework is on the same page. Cute. It's on the same page as last day, page 175, but you're going to do 7 DE, 8 CD, no, BC, 9 BC, just a comma. 11 CEF. 14. Now, what I would like you to practice as well for 7 is the reference angles as well. The reference angles are a repeat of last year. You're taught reference angles last year. But you need reference angles for so much of the solving this year. So make sure you know what the heck you're doing. Reference angles are always positive, and they're from the x-axis to your terminal arm. And you use them for solving last year.